Good afternoon to all. So the next session in our discussion is about DC motor interface. So in the previous we have learned about stepper motor, DC motor. Here normally DC motor we can't directly interface with your microcontroller. Instead we have to use some of the interfacing devices, that is some driver IC we need to include. Why? Because DC motor needs voltages is in the range of 6, 12, 24. But actually from microcontroller we need it can deliver up to 5 volt, and in the ampere which is coming out of the controller is 15 milliampere, but it needs more current. And another one, back EMF is produced by the motor which will affect your microcontroller, so we can't able to directly connect your controller and DC motor. Instead, what is the remedy? We can go for a transistors diodes combining together, forming a circuit which is nothing but a hedge bridge circuit. But that also having some tedious arrangement. We have to connect it manually, all the diodes, all the transistors, resistors, everything. Instead, there is a IC chip is available. It's a driver IC L293D. So with this help of this IC we can able to interface. If you see here the circuit diagram, your microcontroller and your driver IC and your DC motor. So in this what are the applications we can do is, the help of your voltages what we are providing, we can able to control the speed of the DC motor. Normally DC motor is used for some small applications like a movement or a robo, moving robo, all those things we can go for a DC motor. So here two in my circuit diagram I have connected. If you see here, in it is connected to P2.0 and another in 2 is connected to P2.1. So two inputs, and the output of the DC, output of this driver IC is connected to your DC. So here if you are giving two low pulse, low and low, then motor will stop. Low high it moves in clockwise direction, and high and low it is anti-clockwise direction, and high it will stop. And we have to make sure that the particular bit alone we are concerning. And what about the remaining 6 pins of port 2? What will happen is, it will be automatically in a output means high state. Okay, so high state in the sense it is all 1111 value. We are more concerning about the last 2 bits. So last 2 bits alone we are very much concerned. So this is our P2 value will be getting FC, FE, FD and FF. If you are alternatively giving these values to the port 2, so by this way we can able to control our motor. Suppose if we want to move clockwise and we have to stop, and then anti-clockwise we have to stop. So this sequence can be repeated in order to achieve a proper destination. So I'll show you in K. So simple pro. So I'll show you in K how the motor interface, DC motor interface is done. So here a header file and a void delay function, and then your motor pins. We know that P0, 2.0 and 2.1 is connected to your particular motors, and based on the PPT table which I showed you earlier, just making in high, low, high the motor will stop, low, high it will move in clockwise direction, it is anti-clockwise, and then 0 the motor will stops, and then delay program. So here I'll make sure that it is not showing any errors, and followed by debugging, and this is where I want to see the output. And similarly I can able to see in your analysis window also. Just when you run your code, we can able to see the changes. If you see here, the changes FC, FD, FF, FE, whatever we have seen in the table, the values will be keep on repeating. So by this way I can make sure that my code is without running without error. So I can use that hexa code to load into your hardware kit, so that we can able to see the motor running. So by this we are completing our interface peripheral devices with microcontroller, and there is one session left over is a sensor interfacing with microcontroller. I will catch you soon. Thank you.